Hi everybody, today we're going to go over our properties of matter notes. Please make sure that you have your notes in front of you so that you can record your own notes as we go along. So we have density first, and density is going to be defined as the amount of mass per unit volume. So we will make sure that that's highlighted. And we are going to need to know how to apply the density formula, and we're going to use unit labels of grams per centimeter cubed or grams per milliliter. Okay, so let's see if we can make sense out of why that makes sense for us. And so I'm going to draw a little centimeter cubed, and it's not a great picture, and I'm sorry for my picturing. So if I have a centimeter cubed size box and I pour in some liquid, the amount of liquid that will fit inside my centimeter cubed box is exactly 1 milliliter. So 1 centimeter cubed is going to equal exactly 1 milliliter. So that's why you see those two unit labels. One of the unit labels here for milliliters we use to represent liquids and densities of liquids. And the other one we use to represent solids. So just keep in mind that we will use different unit labels for different types of matter, liquids and solids. Okay, so let's go ahead and get into our density equation. And our density equation is written as density is equal to mass over volume. And you will be using this equation a lot, so it'll probably become something that you have memorized. But a cute little way to remember it might be I heart density. Now, the reason why that's all cute and everything is because if we take and we draw a little line in between or across the heart, we end up with m over v, so density is mass over volume. That's a cute way of doing it, but what if we want to just see it as a calculation? So we can set up our calculation triangle having density on the bottom because that is equal to mass over volume. And when I have mass over volume or mass over something, I'm going to divide. And when two things are side by side, I'm going to be able to multiply. And so we'll see how this works. So our first equation, if you go and you put your finger over the D for density, you end up with density equals mass over volume. Well, what about if we want to solve for volume? So if we want to solve for volume, put your finger over the volume in the triangle. So put your finger over the V and you end up with mass over density. And finally, if I want to solve for mass, put your finger over the mass portion. You're going to end up with density times volume. Okay, so those are going to be our three ways of solving based on our use of the density triangle. So let's look at some examples. And so when we read our first example, we can see that it says the density of lead, so let's underline that. The density of lead is 11.35 grams per centimeter cubed. That's 4 significant figures. And we are going to have to round correctly with our answer, so let's make sure we know that. And then it says, what is the mass? Let's put a question mark over that because that's what we're looking for, of a 10 centimeter cubed piece of lead. So this is our volume. Remember, we said centimeters cubed are for solids. Okay, so it's asking us what is the mass. So we're going to use this equation right here. So we're going to use mass is equal to density times volume. So I'm going to have my density. Oh wait, I didn't finish here because I forgot to say that the 10.0 is actually 3 significant figures. Okay, so that's going to be important for us later. So our density is 11.35 grams per centimeter cubed. And we are going to multiply that by our volume, which is 10.0 centimeters cubed. And since I have centimeters in the denominator and centimeters in the numerator, those 2 centimeters, those are going to cancel out. So what I'm going to be left with is really just a unit label that is grams. And that's good because I want mass. So grams goes with that. Now I have to do my math. And when I multiply 10 times 11.35, I get 113.5. But remember, we have to round for significant figures. So rounding for significant figures means I'm going to have to round to the lowest number of significant figures. That means I'm going to round my answer to 3 significant figures. So you are going to have to ask yourself, is the 5 large enough to round the 3 up to a 4? And we should all say yes to that because the rule is 5 or greater, round up. So we end up with our answer of 114 grams of lead for this answer. So there it is. That is our first calculation we're going to do. We're going to try another one right now. What about if we have a mass of a 5 milliliter sample of clay, which is 11 grams. There's our mass. I'm going to label that. That's our M. And my 5 milliliter sample, that's my volume. I'm going to label that volume. Both of these have 3 significant figures for their numbers. So my answers will have to be rounded to 3 significant figures as well. This is asking us what is the density. So I'm going to do this particular one for density. D is equal to M divided by V. So I have 11.0 grams divided by 5.00 milliliters. And my unit labels do not cancel this time. That means my unit label is going to end up as grams per milliliter. And now I just need to do my math, and I'm going to have 11.0 divided by 5.00, and I get 2.2. Exactly 2.2. But remember we said that we had to show our number with 3 significant figures. That means I have to show that 0 on the end. So I added that 0 on, and the reason why that 0 is significant is because there's a decimal in the problem. Okay, we're going to move on and do one more calculation. Okay, so our last calculation of density is if a solid piece of calcium has a density, there is a density of 4.0 grams per centimeter cubed. It's asking us what volume, so we want to know what volume is 24 grams of that calcium. So let's label that one, that's mass. So if we want to know volume from our density triangle up above, we are going to take our mass and we're going to divide it by density. So I am going to plug in my 24 grams of my mass, and let's make sure we all recognize that that is 2 significant figures. And I'm going to divide that by 4.0 grams per centimeter cubed. And before I go on, I am going to be able to see that my grams are going to cancel out, and I'm going to be left with only centimeters cubed for my unit label, which is fine. But when I do this math, I get 3. But I'm supposed to show 2 significant figures, so I'm going to have to show this as 3.0 to show my significant figures. Remembering those rules is always important, so I have provided here the rules for significant figures in this particular part of your notes, so you have those again. All right, let's go on and talk about buoyancy. This is the tendency of an object to be able to float. And the more buoyant the object is, the better it floats. We have something called Archimedes' principle, and it's written really small over here, and we're going to write it bigger, but this time Okay, so Archimedes' principle basically says that the buoyant force of an object is equal to the weight of the displaced water. Okay, so that is all special and everything, and that is the formal way of saying what is the buoyant force, but we also have to be able to relate it so that we have a good understanding of what happens. there is always an upward force that the liquid has on the object, as well as the downward force of gravity of the object. But we want to know what is buoyancy's relationship to density, and we have to say that buoyancy is directly related to density. In other words, more dense objects sink in less dense liquids. And the opposite is true, so vice versa. Less dense objects will float in more dense liquids. Okay, so that's going to be the relationship of buoyancy to density. And so we're going to be able to look at the object and whether it sinks or floats and be able to rank its order of how well does it actually, how does it rank in terms of density. All right, we have one property left, and that is viscosity. It is the resistance of a fluid to flow, and we want to make sure that we have that highlighted because this is one of the ones that gets confusing. A more viscous object is thicker and a less viscous object is thinner. Let's go ahead and put some extra notes here for it. That means that more viscous liquids flow slower. And here's why that's confusing, because those two words are opposite. More viscous means flowing slower. Less viscous liquids flow faster. Okay, so that's why that one is hard to remember. All right, so what does that have to do with density? And it turns out there is no relationship to density. Instead, both density and viscosity, let me spell it right, there we go, are affected by temperature the same way. In other words, adding heat causes both density and viscosity to decrease. And vice versa is also true. So you will want to make sure these are all part of your notes. Thank you, everybody.